Looking ahead, let's imagine that the Coupon Bazaar community members may wish to vote for promotion or removal of certain products. They can do that by using a private voting procedure. But wait a moment, everything on the public blockchain network is transparent, so any votes will be visible to others during the election. And the votes of one member could affect the decision of others. A commit reveal scheme will help us with this problem. Here we have two steps. Commit step. Here we collect encrypted votes by using a hash function and some random string, some salt. A reveal step. Here we're collecting decrypted votes and comparing their hashes with recorded hashes. As you can see, there is no way to change the vote after a commit step is completed. Nobody knows the vote's result before the reveal step is performed. Let's implement that in code. Implementing commit reveal vote is pretty interesting. We have to make a couple steps to reach our destination. But before we go that way, let me describe how this commit reveal voting will work. Actually, we will have two options to vote for every item. You can vote that this item should be featured or delisted. So I define these two variables here, like featured and delisted, just as a plain text. Also, we expect that for every item, we will accept up to 3 votes, and 2 of those 3 votes should reach a quorum, should reach a consensus. So we should get 2 votes featured or 2 votes delisted, and then we will have the final result for every item. Also, for every item, we will have an ongoing process of voting, so we will store the current status of voting for each item. So the status can be voting or reveal. It means that we're in voting status or we got the decision already. So to implement all the needed stuff for commit reveal voting, we have to understand that as the first step at commit stage, we have to send to the blockchain only a hash of our actual vote. But not only a hash. If we always will send the same hash for example, featured text, we'll get the same result and everybody will see our decision. But we have to send the featured text with some salt, with some random value, let's call it so. So, to do that, we have to implement the dApp code and tests. Let's start from the dApp code. Here, as I already said, I defined some variables, some useful variables. Also, I defined some functions to get proper keys for our key value state changes. In the key value storage, we will store the commit messages, let's call them so, the hashes from users. So for every item by every user with suffix _commit, we will store the hash from a user. Also, we will store how many commits we already got for this item. So item ID plus CMT, it means commits count. Also, we will store the reveal message for every vote. So user sends first commit hash, then it sends the reveal value, the actual value. So everybody should be able to validate in the blockchain the vote to see the real vote when we already finished the voting process. Also, we will store the current status of the item, and we'll store the result for every item and for every vote. So we will get, for example, featured for this option voted 2 guys, 1 guy voted for delisted, and we will store it as well. Now let's move to the next functions. We will read some values from the storage. For these keys, we need key value storage readers, so I defined them. They're pretty simple. I'm not going to talk about them too much. And let's move to the most interesting part, to the commit and reveal parts. We have here a vote commit function, which accepts 2 arguments, item ID as a string and a hash of the vote as a string. So we just make some checks here. We get the user's address, how many commits we already have, what is the current status of the voting, and then check those values. First of all, we check that we didn't reach the maximum number of voters. We check that this user didn't vote yet, so we try to read the vote for this user, and only if there is nothing, then we allow him to vote. Otherwise, we say that you voted again and we throw an exception. Also, we check that the item really exists, and we check the current status. It should be voting. So if it is not voting, then we throw a message, voting is not active for this item now. If everything is okay, then we have to update the key value storage. We have to store the commit message, the hash. We have to increase the number of commits count. We have to update the number. And we also should update the status if we reached the quorum or reached the maximum number of voters. So we check that commits count equals to voters, and if so, then we check the status to reveal. Otherwise, it should be voting status. Great. Let's go to the test function for this vote commit function. Here is it. We have a function for vote commit. It actually does only one thing. It invokes the script, our dApp, the vote commit function, and passes two variables. The first variable is item ID. The second variable is vote. What is the vote value? Here you can see that I defined the helper function commit vote and called it 3 times. So my idea here is that we have 3 users. They vote for an item, and I call 3 times because of 3 users. Let me explain how it's gonna work. Here I described also types of votes. We have only delisted and featured. Here we have actual revealed votes, the plain text votes. We have delisted for first user, featured for second and the third. And also we have salts for all these users. For the first user we have random 0, for the second user random 1, and random 2 for the last user. Great. Now let's try to understand what's going on here. We call the commit vote and pass as an argument from the commits array, we pass the first element, and we pass some seed phrase as a second argument. Let's start from the commits. Here we have commits array. It is empty now because we have to set all these values. How to get these commit values? We have to understand how our reveal function will work. So we have to understand how we will check that the hash is correct hash. So we will get back to this commits array a bit later after we talk about reveal function in the dApp. So now let me explain what is this accounts.user0, accounts.user1, etc. What does it mean? It means that here we run a function called setup accounts, which will distribute some tokens, some Waves tokens, to 3 users with these seeds, with seed user 0, user 1, and user 2. It will send to those users some Waves tokens. In my case, I want to send them 0.1 because they should be able to invoke our dApp. So I send them some amount of tokens to use it as a fee. So after we call the setup accounts function, there is a variable accounts in the global scope with this is an object actually with the seeds, so we can use it in our functions. This is very useful helper in the tests, so you can use it in your tests as well. Great, let's understand what should we pass as a commit. To do so, let's get back to the smart contract. Here we have a vote reveal function. We also get the user's address, we get the current status of the voting, and we here increment the number of votes. To be honest, we may use it or may not, but we count it here. And also we get the salted vote. Where is it? We concatenate 3 strings, item ID, the actual vote as a plain text, and the salt as a plain text as well. We convert this string to bytes, then we apply SHA-256 hashing function and convert back to a base 58 string. And we compare it to the commit message, to the hash for the previous function. So we now understand that in the commits array of the tests, we have to do the same. We have to concatenate these three things and to get the SHA-256 from that value. Great. Now let's finish with this vote reveal function. We have here a check that we validate that the hash equals to the hash posted on the previous stage. Also, we check that we didn't reach the maximum number of voters. We check that you didn't reveal your vote already. And we also check that the current status of the voting is voted, not revealed, not something else. So we have to validate that you should not be able to call this function when we already know the result. So we will throw an exception in all these cases. And if everything is okay, then, and we reach the quorum, of course, then we update the key value storage. How? First, we update the reveal key for this user. So we will store there the plain text of the vote. We will also update the number of votes we got already. And if we reached quorum, then we will update the current status. So we will switch it from revealed to featured or delisted. Great. Now let's go back to the tests. Let me explain the tests for vote reveal. Here we also have a reveal vote helper function with three arguments: vote, salt, and seed, three strings. The first one is a plain text of our vote, salt is a plain text of our salt, and seed is a seed phrase for this invocation. We also use invoke script function called the vote reveal function with three arguments: item ID, vote text, and salt text. And we call this reveal vote helper 3 times for 3 users. In the reveals array, we will have the plain text value for the vote. In the salts array, we will have the plain text value for the salt. And in the accounts object, we will have seed phrases for all the accounts. Great. We have now to understand how to get this commit for every user. Here we have a write REPL, which is a very powerful tool. It's a read, evaluate, print loop. It means that we can do something here in write and it will run it immediately. Like we can say 1 + 1 in write and we will see the result, integer value. So let's get the commit messages for all these 3 users. Once again, how we can get the hash for the commit message. We need item plus vote plus salt, and we have to do one very simple thing with it. We have to get bytes, get hash, and convert to base 58. So we'll do this. I have an item ID here defined. Let me take this string. Then I have to add the vote. So for the first user in the reveals array, this is delisted. So I just copy the delisted text. And also I have to put salt, random 0. Great. Now I can run these functions right in the write REPL and get the hash. Here is it. This is for the first user. What about the second and the third users? Let's do almost the same. Let's copy. For the second user, we need featured text, not delisted. So featured, and his salt is random 1. And get bytes and hash and convert back to base 58. Great. Let's do the same for the last user. Here we'll have almost the same code except the random random2, run it, and here we have a hash for our commit message. Great. Now we can run our tests and see what's going to happen. The only thing I want to comment here, the add item function, because we do not need it anymore. We do not want to run it now. So let's run the function and see what's going to happen. First of all, it creates 3 accounts, successfully funded them, it says. Then it commits votes. Actually, there is a way how you can make it working faster. You can run your own private node, your private network, and to use that network with the lower time for block, so it will work faster. But in our case, we use StageNet, so it will take some time. We will provide a link in the description of this video how you can run your private network and how you can work with it. Great, it says that everything is okay, that we committed some votes and we revealed our votes. Let's check it. We have a dApp address here, and we can go to the Waves Explorer and we can check values. Actually, we can see in the key value storage of an account, we can see what's going to happen. So, what is our item ID? Here is it. And let's try to find. Here we have a commit message. It is our hash 3n9, 3n9. And we should also have a reveal message for this 3n9. So here is the listed for the first user. Here is featured for the second and featured for the last. Looks like it works, so nobody will see the results of the voting before we will reach the quorum. But I have to note a couple of things. First of all, this voting was very, very simple. So in this code, I didn't check that, for example, users didn't lock the voting. It means that in my example, if 3 users provided hashes but didn't provide the reveal messages, the voting is locked. Nobody will get the answer. So users can just lock the votings for items and we will never get the result. I didn't implement the checks for these types of potential malicious and suspicious behavior. So just keep in mind that this commit reveal voting was very, very simple.